we have developed a smart helmet with STM32 Nucleo 64 with LoRa WAN transmitter. We have integrated several sensors like wave share sound sensor version 2 and IR flame sensor BME 280, humidity pressure and temperature sensor. At the back of the helmet we have MQ135, which is air quality sensor. We have integrated LoRa WAN transmitter with Nucleo 64 F446RE, and then we have integrated all the sensor with the I2C1 of the board, and we have connected OLED display to the sender side to monitor all the readings. Then we have connected max 30102, which is pulse oximeter sensor. When we place our hand on the sensor measures heart rate and the oxygen level present in the body, and those values are displayed in the display. Currently it is 136 heart rate, and oxygen level is 82 percentage. So on the receiver side we have OLED display connected to Nucleo 144 U575ZIQ. So we have integrated display and LoRa with that Nucleo 144 board. So LoRa pins we have NSS, data in out, MISO, MOSI, SCK. All these pins are integrated with the board to get a readings. LoRa transmitter will transmit the data in bit by bit process. So on the receiver side, we use delimiter to decode those data, and those datas are decoded, and it is allotted to a new variable like CO2 for air quality, pressure, humidity. These are the variables in newly initialized, and these variables has those delimited data, and those data are displayed in OLED. At last we have made two tests, which is air quality test and a flame detection test. In flame detection test we have a candlestick placed near to the flame sensor to monitor a fire incident occurred in an environment or not. uh, fire in Fire incident is occurred means it shows 1, if not occurred it shows 0. So if we place a candle near to it, it shows 1, which means a flame incident occurred. And we have placed smoke near to the air quality sensor, which measures the CO2 contamination level in environment situation. So here the CO2 levels is increasing due to the smoke increasing. So easily can be found that a flame has occurred, and CO2 levels is increasing bit by bit.
This is the setup we developed for ANC. This is the diagrammatic representation on the experimental setup, which will help mining peoples to tackle noise-induced hearing losses and help the mining people to concentrate without the distraction and damage caused by loud equipments. This technology also ensures miners can still hear important sound such as alarms and communication between the co-workers, which improves both individual and overall safety in mining industries. The input side, we are using primary signal, which receives a source signal plus noise signal, and we have the MEMS microphone to capture the input noise signal from the speakers. And we have in the left hand and right hand side, we have the secondary speaker, which will counteracting, and it will produce anti-noise signal to cancel out the surrounding noises which is happening inside industries. And one more thing, we have sound level decibel meter to measure the sound intensity. Initially without ANC, the sound decibel is around 75.7 decibels. When the ANC is on, the sound decibel is around 55.9 decibel. So around 20 to 25 decibel noise cancellation is happening with active noise control. In the CRO, we are showing the system without ANC and with ANC. So in without ANC, the input from the speakers and the input from the microphone are in safe phase. So constructive interference is happening. So whatever noise is coming from the machinery, it will directly go to the mining workers' ears. So this will cause us hearing problems. And in the left hand side with ANC, a noise from the machinery or from speakers and the noise from the anti-noise speakers are in opposite phase. Destructive interference happen inside the noise-free medium, and noises get cancelled each other with reduced level of noise levels.
This is the whole setup. We have the DSP development board with the ST32 ARM Cortex. Here we have the anti-noise speakers with the nuclear boards, and we have the function generator with the provides 1 kHz input frequency, and we have the receiver with the nuclear 145 development with LoRa receivers. So this system has proven to be a reliable and effective solution, solve the unique challenges for mining industry. We developed a proof of concept for ANC. This looks like a big setup, but in future we will implement it inside the helmet using miniaturized speakers for noise suppression.